Title: The $272 million mega crane collapse that flattened a Shanghai business district. Bass drop. The sound of metal under extreme tension. A deep, hollow groan. Then, a deafening metallic crash and the shattering of reinforced glass. Visual: fast, high contrast roll of Shanghai. Luzhui skyline under storm clouds. Graphics flashing on screen. Total weight 400 plus tons. R 172 meters. Settlement 272,000. On the morning of February 5, 2016, a 38-year-old man named Zhang Wei was walking to his office in the dense, high-stakes financial core of Shanghai. It was a routine Friday morning in one of the most heavily monitored, hyper-engineered urban spaces on Earth. He never made it to his desk. Without warning, 172 meters of high-tensile lattice steel came screaming down from the sky, slicing through a packed commercial avenue, crushing a row of vehicles, and killing him instantly where he stood. The ground crew on site actually saw the disaster coming. In those final, panicked seconds, workers were fanning out into the street, desperately waving pedestrians back and screaming for traffic to stop as the colossal machine began its fatal descent. But what almost nobody understood on that freezing morning was that this massive engineering asset had already been placed in apostasy, so fundamentally unstable, so mathematically compromised that it was prepared to topple in barely any wind at all. Visual: text flash. Not an act of God, not bad luck. A pure engineering failure. This is not a story about a freak weather event. It is not an act of God, and it is not a case of bad luck. This is a highly documented, forensic chain of catastrophic decisions that ended with a brilliant life cut short on a Shanghai sidewalk, a record-breaking multi-million-dollar payout, and municipal authorities scrambling to completely rewrite the high-rise construction rulebook for the entire country. And by the time we dissect the telemetry data, you will see exactly why the elite engineering teams who investigated the wreckage never fully agreed on who was truly to blame. Visual: archival images of a massive block-long Art Deco structure surrounded by modern glass skyscrapers. The crane had been deployed on that specific block for less than a week. It was assembled at the end of January for a project that, on paper, was about as routine as heavy lifting in a Tier 1 Chinese megacity gets. The site was the historic 60 Huaihai Road complex. If you live in Shanghai, you've passed it. If you use the internet anywhere in the region, you have actively relied on it. From the street, it is a hulking, monumental Art Deco fortress that fills an entire municipal block, wrapped by critical transit corridors and high-density commercial developments. It started its life decades ago as the central telegraph capital of eastern China. Today, it has evolved into something far more critical: a massive carrier hotel. This building is one of the densest hubs of internet and telecommunications traffic on the planet, with hundreds of global telecom firms routing their fiber optic networks directly through its heavily reinforced floors. An infrastructure hub of that scale runs on an absolute ocean of electrical power and industrial cooling. In the high-density tech sector, that equipment takes a brutal beating and wears out over time. In late January, a specialized mechanical crew arrived to execute a high-altitude swap, replacing massive backup generators and industrial cooling units mounted on the skyscraper's roof. To lift units of that immense weight over 100 meters into the air, the contractor couldn't use a standard tower crane. They needed a serious, heavy-duty industrial weapon. What they brought in was a massive crawler crane, the type of mechanical leviathan that moves on heavy, military-style tank treads rather than wheels, distributing hundreds of tons of dead weight across timber matting. Fully rigged and optimized for high-altitude reach, the assembly stood an astonishing 172 meters tall. It towered over the very infrastructure hub it was servicing, casting a shadow across luxury storefronts and premium commercial real estate. The precise engineering geometry of this machine matters immensely to our story. It was configured with a heavy main boom stretching 59 meters into the air, and mounted directly to the tip of that boom was a luffing jib that extended another 113 meters. A luffing jib of that extreme length acts exactly like a giant steel sail. It catches the wind with terrifying efficiency. And that is precisely why machines of this scale come with absolute Non-negotiable manufacturer manuals detailing exactly what must be done. The moment local weather patterns turn hostile. The crane was owned by one of the largest heavy equipment leasing conglomerates in the region and operated under a specialized rig, ING contract. For the first few days, the high-altitude lifts went off without a single hitch. Then, the East China meteorological forecasts flipped. By Thursday, February 4th, municipal weather bureaus began issuing urgent alerts. A violent winter front was rolling into the Yangtze River Delta overnight, bringing heavy sleet, dropping temperatures, and more importantly, severe, unpredictable wind gusts. This is the exact moment where a routine maintenance operation quietly crossed the line into a fatal sequence of human choices. A crawler crane configured with a 113-meter luffing jib is physically incapable of standing upright when subjected to high-velocity crosswinds. The manufacturer's engineering manual and the Municipal Housing Bureau's safety mandates were perfectly clear. The crew was required to lower the entire boom assembly down to a safe, horizontal resting position and secure it flat against the ground before the storm front arrived. Not in the morning during the storm, but well ahead of time. That did not happen on the night of February 4th. The machine was left fully extended, standing completely vertical through the dark, directly into the teeth of a severe weather system that anyone with a smartphone could see coming. The crane stood exposed, waiting, and by the time the ground crew scrambled into the cab to begin trying to bring the massive steel lattice down the following morning, the wind had already claimed control of the physics. FX. Drum roll, crescendo. Out, please type next or dolly to proceed to part 2. FX. The sound of blizzard wind howling through hollow lattice steel. An ominous, steady ticking sound resembling the onboard computer telemetry. Animated 3D engineering's diagram showing the crane's two-part boom structure against a digital grid. The angles flash. Main boom 73 degrees, luffing jib 51 degrees. The wind directions is represented by red vectors striking the structure from behind. Friday, February 5th opened with a biting cold, heavy flurries and a rapidly stiffening breeze cutting between the concrete canyons of the business district. Sometime just after 8 a.m., with meteorological stations reporting local wind gusts aggressively pushing into the mid-20s in miles per hour, the crane operator climbed into the elevated cab. He engaged the diesel engines and prepared to execute what should have been a standard, highly regulated procedure, lowering the 172-meter lattice structure into a safe, horizontal resting cradle on an ordinary weather day. Lowering a system of this magnitude is a slow, highly controlled, almost boring mechanical maneuver. It relies on massive hydraulic winches, counterweight balancing, and precise cable tensioning to slowly alter the center of gravity. As the massive steel assembly began its slow descent, the ground crew noticed erratic swinging in the upper rigging. Recognizing the immediate danger, they fanned out across the commercial avenue, using bright high-visibility flags to wave pedestrians and municipal transit buses away from the immediate drop zone beneath the machine. It was a fast tactical action that undoubtedly prevented a triple-digit mass casualty event, but it wasn't enough to stop the laws of physics. At exactly 8:25 a.m., the crane reached its mathematical tipping point. The machine let go. FX, a deafening, ripping tier of steel cables snapping under several hundred tons of force, followed by an explosion of impact with pavement and concrete. 172 meters of high-strength lattice steel swung through a terrifying arc and came crashing down across 2 full city blocks of the premium commercial zone. The main boom and the massive luffing jib slammed directly into the asphalt, caving in the roofs of parked executive vehicles and tearing through the ornate stone facades of adjacent buildings. A massive 2-ton hook block, acting as a kinetic missile, punched clean through the reinforced roof of a nearby elite graduate institute. The impact forced an immediate emergency evacuation of hundreds of students and canceled all academic operations for days. Beneath the street surface, the catastrophic kinetic energy transmission ruptured a major municipal water main, flooding the lower utility tunnels with millions of liters of water. Underground gas lines were heavily compromised, triggering emergency automatic shutoffs across the entire district as multiple blocks were rapidly cleared by first responders. Strangely, the massive tracked base of the crane, loaded with dozens of tons of heavy solid counterweights, flipped a violent full 180 degrees into the air, but miraculously remained pinned to its heavy timber cribbing platform. Had that multi-ton base broken free and rolled into the surrounding storefronts, the localized destruction would have been exponentially worse. Within minutes, more than 140 municipal fire rescue personnel and emergency vehicles flooded the disaster zone. A construction worker operating on an upper floor of an adjacent tower caught the entire sickening collapse on his mobile phone. The kind of raw, brutal footage that circulates across global media and that you only ever have to watch once to understand the sheer scale of the violence. And in the absolute center of that pulverized steel and shattered concrete, on a sidewalk he walked every single day, was Zhang Wei. He was just 38 years old, a brilliant mind simply walking to his office when hundreds of tons of structural steel obliterated the sky above him. He died instantly upon impact. 3 other citizens were severely injured in the immediate vicinity. A 45-year-old woman walking near the intersection was struck by flying debris and required emergency medical staples to close a severe head laceration. And a 73-year-old man was trapped inside his vehicle when the falling jib flattened the upper half of his car. A municipal first responder was also hospitalized during the chaotic initial rescue operations. But it was Zhang Wei whom the city could never bring back. And here lies the quiet, profound cruelty of this disaster. Zhang was, by every historical account, one of the most extraordinary minds of his generation. Born in a historic regional town, he had moved to the major economic capitals as a teenager. Initially struggling with the fierce academic competition, he went on to achieve an elite degree in advanced mathematics from Harvard University before returning to the mainland, where he spent roughly 15 years operating as a top-tier quantitative trader at a premier financial firm. The colleagues who worked directly alongside him on the high-intensity trading floors didn't describe the cutthroat, aggressive operator that the financial world is notorious for. Instead, they described a deeply intellectual, unusually compassionate individual who quietly directed a massive portion of his multi-million yuan earnings to rural educational charities and student scholarships. At his memorial service, his widow described the sudden, violent loss as a completely unbearable void. The municipal mayor, surveying the extensive wreckage over the weekend, stated to reporters that given the density of the district, it was a profound miracle that dozens more hadn't been crushed. He was mathematically correct, but it offered absolutely zero comfort to the one family that had just lost everything. So how does an industrial asset of this scale, operated by elite licensed operators in one of the most heavily regulated, strictly inspected construction environments in the world, end up lying flat across a premier commercial district? Pay close attention to this next phase of the investigation, because the true answer wasn't found in the weather reports. The definitive answer had been recorded inside the machine's black box the entire time. Visual, white text on black screen. The telemetry does not lie. The camera zooms in on a glowing digital Kirkwood board. If you are finding this deep forensic breakdown valuable, take a quick second to hit that subscribe button right now. This channel specializes in digging deep into the hidden engineering flaws, structural failures, and institutional short-sightedness behind the world's most expensive high-rise disasters. That's structural failures that dominate the global news cycle for 24 hours and then vanish from public memory. We drop a deep-dive investigative script just like this every single week. The massive crawler crane carried an advanced onboard industrial computer that logged every single mechanical metric, hundreds of times every single second. The precise main boom angle, the luffing jib angle, real-time winch tension, hydraulic pressure spikes, operator switch positions, and error codes. Immediately following the collapse, engineering experts from the manufacturer downloaded this extensive data cache and turned it over directly through the municipal prosecutor's office to elite federal investigators at the National Bureau of Production Safety simultaneously. the Municipal Department of Housing and Urban-Rural Development initiated an independent forensic analysis, retaining top-tier structural engineers from the China Academy of Building Research to mathematically reconstruct the machine's absolute final moments down to a single degree of arc to clear the economic artery of the city. Recovery crews had to use high-intensity oxyacetylene blowtorches to cut the fallen 400-ton steel structure into roughly 35 separate pieces just to haul it out on heavy transport flatbeds. While the debris was cleared, investigators methodically checked all the usual structural failure suspects. They scanned for metal fatigue along the lattice welds, inspected for sheared structural pins, and analyzed the chemical composition of the counterweights. They found absolutely nothing wrong with the hardware. The high-strength steel was completely sound. There was no manufacturing defect. Instead, buried deep within that massive digital data stream was one specific terrifying engineering detail that almost every mainstream news outlet completely missed at the time. At the exact millisecond the system failed, the onboard computer recorded the main boom sitting at an angle of roughly 73 degrees, while the massive luffing jib was positioned at approximately 51 degrees. In that specific, highly extended geometric configuration, the Academy engineers calculated that a steady wind of roughly 26 miles per hour blowing directly from behind the crane would exert enough aerodynamic leverage on that 113-meter steel sail to overcome the entire weight of the base and push the Mach in past its absolute tipping point. But then, the structural specialists ran the complex mathematical equations a second time, and this time they factored in the subtle, real-world structural elasticity, the literal microscopic stretch and deflection that occurs within the crane's massive steel cables, winches, and support bars when subjected to extreme loads at those specific angles. What the computer models spit out defied belief in the exact physical position the crane was held during those final moments. The engineers estimated that the machine's stability had been so violently compromised that it could have been toppled by a wind velocity of just 4 miles per hour. 4. That is not a severe winter storm. That is the literal speed of a human being casually strolling down the sidewalk, in plain engineering terms. By the time the structure came tearing down, this multi-million-dollar mega crane was barely holding itself upright by a thread of gravity. There was no heavy load suspended on the hooks. There was no defective metallurgical part, no snapped cable, and no structural failure from the factory floor. The machine did precisely what the absolute laws of Newtonian physics dictated it must do once human decisions had placed it in that impossible geometric trap. And that entire trap can be traced back to a single choice made the night before. SFX, the low, distant hum of heavy city traffic mixed with the sharp, angry gavel block of an administrative court. Visual, a side-by-side graphic juxtaposition of the collapsed high road crane compared against infamous urban construction failures in China, such as the typical residential block of turnings seen in sector compliance reports. Lag red text overlay, the precedents of urban failure when the final reports were stamped. Both independent investigations, the federal inquiry by the National Bureau of Production Safety and the municipal forensic review by the Shanghai Department of Housing, landed squarely in the exact same destination. The head crane operator, a licensed veteran named Kevin Riley, had committed a fatal operational error. He had fundamentally failed to secure and lay flat the massive 172-meter lattice structure on the night of February 4th, entirely ignoring a severe winter front that every meteorological service in East China had predicted with absolute precision. Then, to make matters worse, he had attempted to lower the towering boom configuration at an incredibly hazardous, unstable angle the following morning into the teeth of rising crosswinds. The municipal authorities did not mince words. The operator, they officially declared, had acted with extreme recklessness. Federal safety watchdogs completely agreed. Had the site management simply ordered the crane to be laid down flat against the cordoned asphalt the night before, exactly as the manufacturer's non-negotiable safety rules mandated, there would have been no structural collapse, no emergency evacuations, and Zhang Wei would have safely finished his morning walk to his financial firm. the professional consequences for the operator were immediate, at least the ones that can be measured in official bureau paperwork. That December, the Municipal Construction Commission suspended his heavy machinery operating credentials. Following a highly intensive 10-day formal administrative tribunal in the spring of 2018, authorities permanently revoked his license. He was personally hit with $52,000 in regulatory fines, though the operator fiercely contested the legal rulings, claiming that shifting site conditions and unpredicted local wind tunnels between the adjacent skyscrapers made the collapse entirely unavoidable. The High Court held its ground. His career was completely over. He would never command a mega crane in a Tier 1 Chinese city ever again. If this engineering disaster ended with the mistake of a single man in a control cab, it would be a simple, tragic case of isolated human error. But this was no longer just about one operator, because the administrative judge, who stripped Riley of his credentials, did something that shook the entire domestic construction industry. She did not stop at the man in the cab, turning the pages of the voluminous engineering logs. The tribunal judge aimed a massive share of the legal blame squarely at the Municipal Housing Bureau itself. Buried in the official trial findings was a stunning revelation. The city's regulatory inspectors had completely failed to spot glaring structural impossibilities inside the project's own engineering paperwork, the specialized safety plan detailing exactly how this 400-ton machine was supposed to be stowed, cradled, and secured during an emergency storm event. A document drafted and signed off by the primary engineering firm and the rigging contractor was completely unachievable in the real world. It laid out an idealized, highly flawed method of securing the 113-meter luffing jib that quite simply could not be physically executed within the narrow spatial constraints of that specific Shanghai roadblock. Yet, despite this glaring physical impossibility, municipal clerks had reviewed the blueprints, stamped them with official regulatory approval, and sent the crew out to execute the lift anyway. Think about the sheer institutional failure of that for a moment. The official municipal line maintained that this was a pure case of operator error, full stop. And mechanically, that was undeniably true. But an independent judicial review of the exact same forensic data concluded that the emergency safety plan the operator supposedly botched was a plan that the city's own housing bureau had legally blessed, even though it was an engineering fiction that could never be followed in a real-world storm. The Department of Housing rejected the judge's systemic critique in the strongest possible terms, digging in their heels and insisting that operator negligence remained the sole proximate cause of the structural failure. This bitter regulatory disagreement was never truly resolved, exposed as a permanent rift in how high-altitude urban safety is governed. To understand why this specific collapse triggered such an immediate wave of institutional panic across the Yangtze River Delta, you have to look at the broader context of China's hyper-accelerated urban expansion. This was far from the first time that the nation's premier economic hubs were forced to violently confront the hidden risks of heavy lifting and high-rise construction. The rapid build cycles that defined the early 2000s across elite business districts like Shanghai's Luzhizui, Beijing's CBD, and the sweeping waterfront developments of Shenzhen had seen their own share of high-profile industrial close calls and structural failures. Domestic engineers were already locked in intense debates regarding soil settlement, concrete curing volumes in mega foundations, and the unpredictable wind aerodynamics created when massive glass curtain wall towers are placed close together. Only years prior, massive national headlines were made when a nearly completed 13-story residential block in a nearby sector completely tipped over flat onto its side due to improper soil excavation and weight distribution, exposing systemic cracks in regional site supervision. With public trust around urban megaprojects already highly sensitive to safety headlines, the Huaihai Road crane collapse became an absolute line in the sand. The political and social blowback of allowing a 172-meter steel tower to literally flatten a premium commercial district on a weekday morning was something the municipal leadership refused to tolerate. The response from the state was lightning fast. And this time, it was completely sweeping. Within mere hours of Zhang Wei's tragic death, emergency decrees were broadcasted from the capital. Officials ordered an immediate total freeze on every single active crawler crane and high-altitude tower crane operating across all 15 municipal districts. In a single unprecedented afternoon, a total of 376 massive crawler cranes and more than 50 industrial tower cranes were ordered to completely halt operations. Locked down and inspected in place across the city's vast skyline, the municipal mayor rapidly formed an elite, multidisciplinary crane safety working group composed of top structural minds from the China Academy of Building Research and global heavy lifting consultants. Over the following months of intense bureaucratic negotiation, Shanghai completely tore up and rewrote its structural safety codes for dense urban environments, setting off a regulatory chain reaction that would soon alter construction sites nationwide. FX. The low detonating of a hydraulic pressure valve releasing, followed by the distant, sharp echo of sirens weaving through heavily congested urban canyons. The sound of water gushing forcibly underground. Visual, high-resolution forensic photographs, the crisis perimeter at Weihai Road. Writing red map, illustrate the immense discussion radius, cutting across multiple traffic lanes and tearing gaunt holes into commercial block corners. The text overlay bilbs, debris zone, 2 full municipal sectors. The newly established safety directives transformed Shanghai's construction sector almost overnight, imposing a tight regulatory net that sent shockwaves through high-rise development firms across East China. Under the new, uncompromising municipal mandate, the exact crane configuration that had caused the disaster, a crawler crane utilizing an ultra-long luffing jib that required work to halt at wind speeds of 20 miles per hour or less, was banned from operating on public city streets entirely. The risk profile was simply too volatile for a high-density, Tier 1 metropolis. Furthermore, the revised building codes dictated that every single crawler crane operating within urban boundaries had to be retrofitted with state-of-the-art anemometers, specialized, real-time wind measurement instruments wired directly into the operator's main cabin computer, ensuring that no site manager could ever again claim ignorance regarding local wind gusts every complex. High-altitude lifting operation was now legally required to employ a dedicated, state-certified lift director on site. This individual's sole legal responsibility was to monitor localized meteorological data, oversee structural balancing, and maintain a clear, cordon safety zone for pedestrians below. The city also established a strict 25-year operational age limit on heavy cranes permitted to work near municipal thoroughfares, while simultaneously doubling the regulatory fines for any contractor failing to properly lower and secure heavy equipment ahead of a documented weather front. New York and Tokyo had long been cited as the global benchmarks for urban crane safety, but after the Weihai Road disaster, Shanghai's rules leaped ahead, becoming some of the toughest, most unyielding engineering mandates on the planet. Predictably, the domestic commercial construction lobby didn't take the sudden regulatory squeeze sitting down. Several major industry associations and state-backed development consortiums quietly initiated legal petitions to roll back the more extreme wind restrictions. They argued fiercely that no other major construction market in the world treated a routine 30-mile-per-hour wind gust as an automatic reason to shut down a multi-million yuan commercial project and freeze regional infrastructure development. They warned that these over-engineered rules would trigger widespread project delays, driving up the cost of luxury high-rise developments and public transit megaprojects alike. But the Municipal Construction Commission stood completely firm. The image of 172 meters of crumpled steel lying across an economic artery was an institutional nightmare they were determined never to repeat. While the bureaucrats and corporate lawyers clashed in air-conditioned boardroom meetings, a far more intense, high-stakes battle was playing out in the legal courts over the financial and human cost of the disaster. The sudden, violent destruction of that Friday morning had generated a mountain of structural and civil liabilities. The civil lawsuit filed on behalf of Zhang Wei's grieving family, alongside the other citizens who had been maimed or trapped within the debris zone, did not target an isolated company. The legal team filed a sweeping, comprehensive claim that named the entire operational chain of command. It targeted the mega crane's corporate owner, the primary rigging contractor, the high-altitude engineering firm that drafted the flawed safety plan, the wealthy private developers of the 60 Shanghai Road Tower, and the Municipal Housing Bureau itself for stamping their approval on an impossible plan. The initial compensation claim filed by Zhang Wei's widow was unprecedented, seeking an astronomical $600 million to account for the catastrophic loss of life, the immense future earnings of a top-tier quantitative trader, and the profound emotional trauma inflicted on the family. For months, the corporate defendants attempted to deflect blame onto one another. The crane owner blamed the operator. The contractor blamed the unpredicted wind tunnel effects of the surrounding skyscrapers, and the engineering firm claimed their paperwork had been misinterpreted. But as the forensic computer telemetry from the crane's black box was read into the official court record, the defense collapsed. The data proved beyond a shadow of a doubt that the machine had been placed in a position of near-zero stability due to a series of easily avoidable human choices. The resulting legal resolution broke every existing record in domestic judicial history. To avoid a prolonged, highly publicized trial that would continuously expose the regulatory vulnerabilities of the city's building department, the defendants collectively agreed to a historic, multi-party settlement of $272.5 million. To this day, that staggering figure remains the largest crane accident settlement in regional history, and one of the largest single-casualty construction disaster payouts ever recorded anywhere on Earth, more than $250 million in cash, directly traceable to a single structural boom lowered at an improper, reckless angle on a freezing morning when the entire machine should have been lying completely flat on the asphalt. When you strip away the massive financial figures, the corporate finger-pointing, and the dense legal transcripts, you are left with the raw, devastating human reality of what occurred on that sidewalk. The sheer engineering irony is almost too painful to consider. The physical collapse was entirely, 100% avoidable. The winter storm warning had been broadcast across every local television station and weather application hours in advance. The manufacturer's instruction manual was perfectly explicit regarding the wind-catching properties of a 113-meter luffing jib. The municipal safety rules left absolutely no room for interpretation. The heavy machinery crew possessed every single piece of information required to prevent the tragedy, yet they chose to leave the massive crane standing tall through the dark, forcing a desperate, panicked crew to try and wrestle a 400-ton mechanical leviathan to the ground in the exact high-velocity wind conditions it was never physically built to withstand. And because of that sequence of choices, Zhang Wei's journey came to a sudden, violent end. He was a man who had overcome immense odds, leaving his quiet regional town as a teenager with limited prospects, fighting his way through the grueling academic systems of his youth to eventually claim a seat at one of the world's most elite universities. He had returned to his home country not to exploit his brilliant mathematical mind for pure personal greed, but to build a substantial life that quietly uplifted those around him, using his success to fund the dreams of underprivileged children across the provinces. He was just 38 years old, at the absolute peak of his intellectual and philanthropic powers. The engineering data proves that he wasn't killed by an unpredictable whim of nature. He was killed by a giant steel machine that had been rendered so unstable by human neglect that a soft, passing breeze was enough to bring it roaring down on whoever happened to be standing beneath it. Today, the physical scars of that morning have been completely erased from the pavement of Shanghai Road. The ruptured water mains were patched, the mangled asphalt was completely repaved, and the shattered stone facades of the neighboring commercial blocks were meticulously restored to their pristine, premium state. The historic Art Deco fortress at 60 Shanghai Road, the old telegraph capital that once connected the nation via wire, continues to sit silently on its block, its upper windows offering no hint of the chaos that unfolded beneath them. Inside its heavily reinforced floors, thousands of industrial servers hum in the darkness, generating immense heat as they quietly route a massive vital slice of the regional internet, completely indifferent to the structural tragedy that once played out right on its doorstep. Set effects the low, unyielding industrial hum of thousands of combined Ethernet servers, a steady, vibrating drone that fades into the back noise of a busy metropolitan commercial district. Visual, wide shot of a modern Chinese financial sector at dusk. Towering glass skyscrapers light up one by one. Logical data lines texture the screen, representing urban density and risk profiles. Text overlay. The future of the urban skyline. The permanent legacy of the Shanghai Road disaster is not found in the record-breaking legal settlement or the shredded career of a single crane operator. It is found in the invisible lines of risk management that now govern the construction of every single luxury skyscraper, transit hub, and mixed-use megablock across China's expanding urban centers. The sheer economic reality of the modern Tier 1 city means that developers are constantly playing a game of inches, pushing structural assets to their absolute limits to build faster, higher, and more efficiently within incredibly tight spatial footprints. But as the forensic reconstruction of this failure proved to the global engineering community, a system that is built to the absolute edge of its tolerances leaves zero margin for human error when the environment shifts. Across the nation's premier economic zones, from the high-tech corporate parks of Shenzhen to the massive, river-linked skyscrapers of Chongqing, the lessons of this specific crawler crane failure are actively studied by structural engineering students and elite construction superintendents alike. It serves as a stark, textbook warning against the dangers of institutional complacency on a project site. When a construction plan becomes an idealized document meant to satisfy bureaucratic checklists rather than a functional, real-world field guide, the safety of an entire municipal sector is compromised before a single lift even begins. The structural engineering community now recognizes that the aerodynamic behavior of massive equipment inside modern concrete canyons is vastly more complex than traditional manufacturing manuals assume. When towering structures are grouped closely together, they create unpredictable microclimates, localized wind tunnels, downdrafts, and vortex shedding that can amplify a routine breeze into a destructive force. The China Academy of Building Research has spent the years following the disaster mapping these high-density urban wind patterns, integrating advanced fluid dynamics into the layout of every major municipal infrastructure job. The goal is simple: to ensure that no machine is ever again placed in a geometric configuration where it is forced to fight the invisible forces of a changing skyline without a viable, executable escape plan. If you want to keep exploring the hidden engineering flaws, the institutional cover-ups, and the dramatic structural failures that define the world's most ambitious and expensive megaprojects, the critical stories that dominate international news for a single day before vanishing behind corporate non-disclosure agreements, make sure to stick around, subscribe to the channel, hit that notification bell, and leave your thoughts on who truly bore the responsibility for this disaster in the comments below. Was it the operator who failed to drop the boom, the rigging contractors who drafted a flawed safety plan, or the municipal bureau that stamped their official seal of approval on an unachievable engineering fiction? The heavy machinery has long since been hauled away. The multi-million-dollar compensation packages have been distributed to the lawyers, and the strict new municipal safety guidelines have been integrated into the digital systems of construction cranes across the country. Yet, the essential truth of the disaster remains completely unchanged. Zhang Wei left his historic regional home as a young man, mastered the complex world of high-finance mathematics on another continent, and returned to build a legacy of profound personal generosity, only to have his life extinguished on a familiar sidewalk by a 400-ton machine that was exactly one soft wind gust away from total structural collapse. And right there on the very same blow, Ski, the massive, imposing Art Deco fortress of the 60 Shanghai road carrier hotel, continues to stand completely undisturbed. Its heavy stone facade absorbs the changing seasons, Its backup generators sit ready on the roof, and its high-density server racks continue to blink in the dark, quietly, efficiently routing an absolute ocean of internet data across the planet, moving forward as if that terrifying Friday morning had never happened at all. There is always another high-rise project breaking ground, always another heavy asset rising into the clouds, and always another story waiting to be told.